Hello everyone, and welcome to my channel. This is an educational channel. We look at spend a lot of our time looking at theories of everything. We do deep dives on great theories, great research from people you probably never heard of, but if you did, you'd be happy about it. And today is our 420th video on Dewey B. Larson and his reciprocal system of theory. We're looking at one of his books that is called The Basic Properties of Matter, Chapter 2, Inter-Atomic Distances. And we are right in the middle of that chapter. We'll get into that as soon as I give you a little bit more background. Mr. Larson's theory was first put out in 1959, where he put out his two fundamental postulates. Just two sentences about how the universe operates. Then he took those two postulates and through a process of deduction, he arrived at his theoretical universe. And so this theoretical universe was through an if this then that approach, was what Larson's universe would look like if his postulates were correct. And then in many books he compared his theoretical universe with the actual measured universe of the scientists that they've compiled through experiments in their laboratories and putting together in their scientific tables. And that's exactly what Basic Properties of Matter is. Larson's book, it's on chemistry, some of the basic properties of matter, like the melting point. And we are looking at the chapter that's called the Inter-Atomic Distance. Every element has a distances between each atom when they are kind of packed together in the solid state. And that is what Larson derived an equation for, more than one equation, depending on different factors within the atom, its location on the periodic table, and so on. And then he compares his results with the scientific tables. Now, most of Larson's content is in his first postulate, which is paraphrased as the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, my version of it will be a little bit longer, but just that the universe is not made out of matter, it's not made out of energy, it's not constructed of the fundamental forces, but it is made out of motion. Specifically, it's made out of a motion that Larson calls scalar motion, which is a non-localized, generalized kind of motion that has a magnitude but no specific direction. You can envision a scalar motion with a balloon that you put dots on with a magic marker. If you blow up the balloon, all of the dots will be moving away from each other. And if you suck in the balloon, all the dots will be moving toward each other. But they're not moving in any specific direction. They are just all moving away from each other or toward each other. You wouldn't be able to determine a specific direction until you arbitrarily assigned one of those dots to be motionless. And then you would be able to start making measurements. So the direction measurements are product of the reference system, not of the motion itself. And Hubble and his associates back in the 20s did observe that all of the distant galaxies are moving away from each other. So this is not just an imaginary motion that you make up with a balloon. It's actually got physical counterparts. The motion of the distant galaxies is a motion outward in all directions. Now, the people that use that as a justification for the Big Bang, that is one interpretation. But I think in order to make that interpretation, you would have to be, again, saying that our galaxy is not moving. All the other ones appear to be moving outward in all directions, except for ours. So that's gets into like a Copernicus type question. And the results, the mathematical results, are the same either way. So it's not like you can really tell from once you assign a reference point, once you assign a stationary point, the measurements are going to look the same from a mathematical standpoint. Now, so Larson says the universe is made out of motion, in particular this kind of scalar motion. That is what the universe is built upon. He says that if you don't have anything in the universe, you still have motion. You have to be able to accept the idea that motion comes before the thing that's moving, and that even before you have anything in the universe, you have this outward motion, which Larson calls the progression. And that motion occurs, basically, motion is the relationship between space and time. We tend to think of motion as being, and all other activity of the universe as being on a stage of space and time. Like the space and the time are the container of the universe. But in Larson's system, space and time are the contents of the universe. The universe is made out of motion, and motion is made out of the relationship between space and time. Motion is basically a fraction with space or time as the numerator and time or space as the denominator. That sets up a generalized reciprocal relationship between space and time. Space and time are both the same, except that they are reciprocals of one another. So they come in like a different order. The same way 3 halves and its reciprocal 2/3 are have the same components, but they are in reverse order, and they also multiply to be 1. And also with space and time. So Larson says that space and time and motion occur in 3 dimensions. So motion is a fraction with space or time as the numerator, time or space as the denominator, but they can come in multiple dimensions. And so, all of our scientific quantities are kinds of motion. Speed is space over time. Energy is time over space. These are the simple aspects, but if you want to get more complicated, matter is time to the 3rd power over space to the 3rd power. Density is time to the 3rd power over space to the 6th power. Because density is just matter over volume. Volume is space to the 3rd power. So time to the 3rd power over space to the 3rd power divided by space to the 3rd power is time to the third over space to the sixth. Pressure is time over space to the fourth power. So you can think of pressure as time over space, which is energy, over volume. So pressure is energy over volume. You can also think of pressure as force is time over space to the second power. So you can also think of pressure as force per area. Force's conjugate acceleration is s over t to the second power. Momentum is t to the second power over s to the second power. And on and on and on. So that just shows you that Larson has an alternate system to the MKS system, and it is much more efficient because it only has 2 variables instead of 3. Makes things a lot more clear, and you can check your equations also. Now, the other important thing among many things, though, is that space and time only come in discrete units. You have to have a full unit of space before you have space. You have to have a full unit of time before you have time. If you have exactly 1 unit of space in exactly 1 unit of time, you have the speed of light, which Larson refers to as unit speed. 1 over 1 equals 1. This speed of light in Larson's system is the background speed of the universe. So this is the pace of the outward progression. The progression is outward at the speed of light in all directions. That is the empty universe, or the origin. Larson refers to it as the progression of the natural reference system, the null point, the 0 point. This replaces the 0 point of the scientist, which is zero motion. Larson measures his motions from the from this unit progression from the speed of light outward in all directions. That's why he calls it a speed displacement as opposed to a speed, because there was already a speed there. So it's the difference of the speeds instead of just the speed. So he calls it speed displacement. And this basically means that if you have the speed of light outward in all directions is the 0 point, that means that half of the universe is actually moving faster than the speed of light, which goes against the legacy scientists again, who say that the speed of light is the maximum speed of the universe. That shows that they are not aware of half of the universe, only the half that's moving slower than the speed of light, which Larson calls the material sector, but not aware of the cosmic sector, which is what Larson calls the faster than the speed of light. Now, when you cross that boundary from one to the other, you have to invert the order, invert the roles of space and time. So in the material sector, we generally see 3 dimensions of space in a still frame, what we call coordinate space, XYZ coordinates or volume, and that is also, what you call the spatial reference system. We see 3 dimensions of space in a still frame, and we see clock time, which is the flow of time, the progression of time, the scalar motion outward in time. Time is always getting farther and farther and farther apart, or later and later, the progression of time. So in the material sector, we have coordinate space and clock time. But if we cross that boundary, that speed of light boundary, and we move into the cosmic sector, into the faster than light sector, then we see coordinate time and clock space. So we see 3 dimensions of time in a still frame. And we see the flow of space or progressing space. Space is always getting later and later and later. Our space is always getting farther and farther and farther apart, like the dots on an expanding balloon. In addition to that one boundary, there is also a boundary within each one of those sectors that is that leads to a small region or inside region of each sector, and that is when you do not have a full unit of space or time. Because if you don't have a full unit, you don't have. If you don't have a full unit of space, you don't have space. You only have time, because the universe is made out of space and time. So it has to be one or the other or both. And so Larson calls that the time region. That is the interaction that occurs in less than 1 unit of space, which is 4.56 times 10 to the minus 8 meters, or like 1/500,000th of an inch. When you have interactions that occur in less than that amount of space, they occur in time. And that is a boundary, again, that you cross. So that is the realm of atomic and molecular interactions that he talks about here in this Basic Properties of Matter book. In the cosmic sector, you have the same thing, but with time. Within 1 unit of time, you don't have time, you only have space. So Larson calls that the space region. And that's the region of interaction of cosmic atoms and cosmic molecules, what are known as mesons or antimatter. And when you cross these boundaries, the rules also invert. And so, or they, the directions invert. So inside the time region, you have progression. The progression is moving everything toward each other, towards zero space. And you have gravitation, the opposite of the progression, the contracting balloon in the earlier analogy, that is now moving everything away from each other toward unit distance. Okay, so that is where you get this concept Larson has of the inter-atomic distance. That is the place within the time region where the constant rate of the progression is completely balanced or equal to the variable rate of gravitation. So where gravity equals the progression is where you have this interatomic distance. Now in this chapter, he's a little bit in the weeds here, talking about the different kinds of matter, the different divisions of the periodic table. And each one of the different divisions is dealt with slightly differently. Basically, we're talking about one equation, but there are certain caveats that we have to take into account. These are more finer points, but I'm just going to read them, read everything, and don't worry if you don't understand all of it, if you kind of get the basic idea. This is our 6th installment of this chapter, and we did, I think, about 10 videos before this. So you might want to go back if you want to get all the details of the equations. A special type of structure is possible only for those electronegative elements which have a rotational displacement of 4 units in the electric dimension. Now again, an atom is made out of 3 separate kinds of rotation. First, it's made out of 2 photons that are simple harmonic motions, wave-like motions. Now, there's a debate between Larson and some of his followers how that wave-like motion gets established, whether it is from a vibrational motion or whether it is from 2 rotational motions. But regardless, there are 2 photons at the core of every atom, but those photons are moving outward at the speed of light in all directions, like the progression, until they are slowed down by rotations. There have to be 3 dimensions of rotations to slow down and stop the atom and get it to start gravitating. And those rotations are notated in Larson's periodic table. So every element of the periodic table has a 3-number signature. The first number is the primary 2-dimensional rotations. The second number is the secondary 2-dimensional rotations. And the third number is the electric rotation in the opposite direction, which these are scalar motions, so they don't have direction per se. The only direction that scalar motion has is in or out. Okay, so that third dimension is in opposition, but the third dimension is only optional. It can be 0. In all of the noble gases, it's 0. And it can be positive or negative, kind of in the same way that valence is, where something like oxygen has is 2 steps away from the nearest noble gas, neon, that's -2, but you could also think of it as +6 toward the next noble gas, helium. And that's kind of what he's getting into here. There are different orientations of some of these elements, and depending on where it's located on the periodic table, there are certain other factors you have to keep in mind. These elements are on the borderline between division 3 and division 4. When they have a displacement of 4 units in the electric dimension. The electric dimension is the 1-dimensional, so that is the third number. So when that number is 4, these elements are on the borderline of division 3 and division 4, where the secondary positive and reverse orientations are about equally probable. And again, probability is one of the major factors that Larson uses to deduce his universe based on what is possible and what is probable. And also the idea that what can exist does exist. Under similar conditions, other elements crystallize in the hexagonal or tetragonal structures, utilizing the different orientations in the different dimensions. For these displacement 4 elements, however, the 2 orientations produce the same specific rotation, 10. The interatomic distance in these crystals is therefore the same in all dimensions, and the crystals are isometric, even though the rotational forces in the different dimensions are not of the same character. The molecular arrangement in this crystal pattern, the diamond structure, shows the true nature of the rotational forces. Outwardly, this crystal cannot be distinguished from the isotropic cubic crystals, but the analogous body-centered cubic structure has an atom at each corner of the cube as well as one in the center, whereas the diamond structure leaves alternate corners open to accommodate the abnormal projection of forces in the secondary positive dimension. In those of the lower elements of division 4 that are beyond the range of the inverse type of orientation, there is no available alternative for combination with the secondary positive orientation. The crystals of these elements therefore have no effective electric rotation in the remaining dimensions, and the relative specific rotation in these dimensions is unity, as in all dimensions of the inert gas elements. So the specific rotation basically is 1 plus, in these applications, it's 1 plus the C number, the third number. In this case, the third number. That's why for the inert gases, it's unity as opposed to zero. Because you have to have one, in all of the reciprocal system applications, you always have to have that one unit just to get started, because that one unit is what nullifies the progression in that dimension. The progression is always a unit, so it has to be nullified just to get you to zero. Okay, the most common distances in the aggregates of the division 4 elements are shown in table 5, which I think we'll get to here. Up to this point, no consideration has been given to the elements of atomic number below 10, as the rotational forces of these elements are subject to certain special influences which make it desirable to discuss them separately. One cause of deviation from the normal behavior is the small size of the rotational groups. In the larger groups, of the 4 divisions are distinct, and except for some overlapping, each has its own characteristic force combinations, as we have seen in the preceding paragraphs. In an 8-element group, however, the second series of 4 elements, which would normally constitute division 3, is actually in the division 4 position. As a result, these 4 elements have, to a certain extent, the properties of both divisions. Similarly, division 1 elements of these groups may, in some cases, act as if they were members of division 3. A second influence that affects the forces and the crystal structures of the lower group elements is the inactivity of the rotational forces in certain dimensions that was mentioned earlier. A specific rotation of 2 units produces no effect in the positive direction. The reason for this is revealed by equation 1-1. By applying this equation, we find that the effective rotational force, which is the log of t, natural log of t, for t equals 2 is 0.693, which is less than the opposing space-time force of 1. The net effective force of specific rotation 2 is therefore below the minimum value for action in the positive direction. In order to produce an active force, the specific rotation must be high enough to make the natural log of t greater than unity. This is accomplished at rotation 3. Okay, so I think I might have told you that you have to be able to nullify 3 dimensions of the progression, all 3 dimensions of the progression, before you kind of stand still and are able to gravitate. I believe that is a different explanation than what he's giving here, which is for the specific rotation, and this is based on the natural log, which he derived in the equation for this interatomic distance. And the natural log is also, you have to have 3 in order to get a natural log greater than 1. And so you need 3 units of specific rotation here in order just to get any type of force that will nullify the progression. I'll have to look into kind of the differences there, but we will suss it out. This is, again, is kind of a detective story. You kind of just get clues and you stash them in the back of your mind, and eventually he kind of solves the problem. You know, he kind of says it later, but you know, you can't blame Larson because he's working on his own with no resources, you know, to put this together. And he did a fine job, but not everything is on a silver platter for you. You know, he didn't have the time or resources to roll out the red carpet. So you gotta dig, and you gotta, you know, be somewhat of a detective or a bulldog. Okay, now we're talking about division 4 elements here. And so he goes through the table. We got silicon, the specific rotation 3-3 on either 5 or 10. Observed 2.31, and again that is in angstroms. Calculated 2.31, observed 2.35. Phosphorus calculated 2.19, observed 2.20. Second orientation of phosphorus calculated at 3.46, observed at 3.48. Sulfur calculated at 2.11, observed at 2.07. Second orientation of sulfur calculated 3.21, observed 3.27. Chlorine calculated 1.92, observed is only 1.82. So that is a fairly significant error there. Chlorine 2.48, calculated, observed 2.52. Moving up to the next row on the periodic table, germanium 2.46, calculated, observed 2.43. Arsenic 2.37, observed 2.44. It's again fairly significant difference. The second orientation of arsenic 2.46, observed 2.51. Selenium calculated 2.32, observed 2.32. Second orientation of selenium 3.46, observed 3.46. So he's on a roll. Okay, and it goes on and on. There's a fair difference here with bromine, however you pronounce it. Tin, he got exactly right there for one of the orientations, but significant differences in one of the other ones. And it goes on and on. So we will resume tomorrow. He will probably explain a little bit about this table and then probably move into a different group of elements. Hang in there, and thanks for tuning in.